Let's understand how to apply chain rule and evaluate derivative at a given point. So here we need to evaluate dy dx at x equals to 9, and we are given two functions, y as a function of u, which is cube root of 4u, and u as a function of x, which is 5 minus square root of x. And we need to evaluate dy dx at x equals to 9. So if x equals to 9, what is the value of u? It's a good thing to do it right in the very beginning. So 5 minus square root of 9, that gives us 5 minus 3, and that is 2. So u is 2 at this point. Okay. Now let's start with derivative of y. So we are given y equals to, so I'll write this as 4u to the power of 1 over 3. That's the cube root, right? So y dash, I should not write y dash. Let me use Lebanese notation, dy du. You will understand the advantage. I know we are differentiating y with respect to u. If I write y dash, you don't know whether it is with respect to x or u, correct? There is a confusion. So this is a better notation to use in chain rule. So we get 1 over 3 times 4u to the power of 1 over 3 minus 1. That gives us, now 1 over 3 minus 1 will give us minus 2 over 3, right? So we get 3 here, and then we have 4u to the power of, since it is minus 2 over 3, I brought it down, right? So we'll just write 1 here, 2 over 3, correct? So that is what we get in the denominator. Now, let's find derivative of the second function with respect to x. So the second function for us is u equals to 5 minus square root x. So we have du over dx equals to, derivative of a constant is 0, and for negative square root x will be negative 1 over 2 square root x. Now we know these two derivatives, then we can always find dy dx, right? So dy dx is product of these two. So let's write down dy dx now. So we have dy dx, which is equals to dy du times du dx, right? So for us, dy du is 1 over 3 4u to the power of 2 over 3, and ddx is minus, remember, minus 1 over 2 square root x. So that's the derivative. Now what we need to find actually is dy dx at x equals to 9. We calculated at x equals to 9, u is 2. So let me write u as 2 here, right? So in that case, I don't really have to write u as this and expand this complicated part. Now we can substitute these values and calculate. So we have 1 over 3, 4 times u, which is 2, and then we have to the power of 2 over 3, right, times minus 1 over 2 square root of 9, correct? So that is the expression we get, which we can now evaluate. So we can find this as equal to 1 over 3 times, now 4 times 2 is 8, right? Cube root of 8 is 2, and 2 square is 4, so we get 4 here, correct? Now this one is minus 1 over square root of 9 is 3. 3 times 2 is 6. So we get this. And now we can multiply them. Minus 1 in the numerator, and 6 times, 12 times 6, 72. Either way, right? So we get minus 1 over 72 as our answer for this particular thing. So we get dy dx. Now we can write down our answer as dy dx at x equals to 9 for the given function is equal to minus 1 over 72, right? So I hope you understand the steps. So what we did was, first find dy du and du dx, right? It's a composite function. Y is a function of u and u is a function of x. Since it is a composite function, we need to use chain rule. Dy dx equals to dy du times du dx. So we had these values here, where you substituted, And then, since we need to evaluate dy dx at x equals to 9, and at x equals to 9 we found u as 2. Substitute those values and get your answer. So that ways you can solve such problems. Thank you.